All right, so here's your review. So number 1, A. It says, among which of the following numbers could be the probability of an event? You could have a probability of 0, meaning it's not likely. Negative 0.01, not possible, can't have negative numbers. 0.75 is good. 0.41 is good. 1.34, not okay because it's too big. Part B, which of the numbers can be? 2/5 is a good one. 1/3 is a good one. Negative 4/7 would not be because it can't be negative. 4/3 cannot be because it's above 1. And 6/7 can be. So on that type of question, that number 1, you're going to have one like that on your quiz. Okay, just tell me which one cannot happen or can happen. Okay, number 2 says find the probability for the event E happening. So your sample space, when it gives you S, says red, green, blue, get that out of the way, orange, yellow. That's your sample space. So those are the colors we have to choose from. It says a yellow. So for number 2, a yellow would be 1 out of 5 because there's 5 colors to choose from and you're choosing one of them. F says green or orange. There's a green and an orange. There's 2 of those out of 5. Red or blue or yellow. Red or blue or yellow. There are 3 out of 5. Or if you really wanted to do 1/5 plus 1/5 plus 1/5. Suppose that E equals yellow, compute the probability of EC. So on number 5, just to remind you, when it says EC, that's the complement of event E. So if the event E is 1/5, then the complement of that is 4/5. Because remember, they need to make 1. So that's why number 5 was that. Okay. Number 6. Suppose P of E is 0.76 and P of F is 0.45 and E and F was 0.32. What's P or E? So this is the addition rule. And this is the general addition rule because you have that and stuff. So that's the formula E or F, given that the probability of event E plus the probability of event F minus the probability of E and F. So 0.76 plus 0.45 minus 0.32 . So I forgot to hit a point, decimal point. What? I get 0.89. Number 7, same type of thing, as long as they're mutually exclusive. If they are mutually exclusive, then that just goes back into like disjointed rules, which just means just add them. So when number 7, when it says that, if they're mutually exclusive, meaning that they have nothing to do with each other, then you simply just take and do this. You add them. So 0.36 plus 0.12 equals 0.48. That's number 7. On number 8, it says suppose E and F are independent. Okay, so independent. Now, when we're doing in addition, it gives us that P of E was equal to 0.45 this last one? Yeah. And P of F is equal to 0.2. I guess I don't need that parentheses there. What's the probability of event E and F occurring? This is the multiplication rule for independent events, where you take the probability of event E times the probability of event F, or 0.45 times 0.2, which gives you 0.09. That's number 8. Okay, so that's the first part of it, 1 through 8. All those formulas, just so you guys know, are found on page 308. They're kind of in a nice little, in order. They're all there. They would all be, honestly, the ones that are listed there on the formulas on page 308. They're everything on the left-hand side. The right-hand side is the back half of the chapter. Okay, so that was 1 through 8. Number 13 says, in roulette, the game of roulette wheel consists of 38 slots, numbered 0, 00, 1 through 36. To play the game, a metal ball is spun around the wheel and allowed to fall into one of the numbered slots, and goes on to there. Determine the probability that the metal ball falls into a green slot. So it says 0 and 00 are green, and the rest are either red or black. So that probability for number 13 is 2 out of 38, because there are 36 numbers plus the 2 green spots, which reduces to 1 out of 19. That's 13A. 13B, determine the probability that a metal ball falls into a green or a red slot. So green or red. So if there's 36 different numbers, and half of them, so 18 of the 36, would be, not 36 numbers total, 38 numbers total. 18 of them would be red, and then 2 of them are green. That's the other one, green. So if you combine those together, you get 20 out of 38, which reduces down to 10 over 19. Part C, determine the probability a metal ball falls into 00 or a red slot. So 00 would be 1 out of 38. Red slot would be 18 out of 38. And if you add them together, you get 19 out of 38, which reduces down to 1/2. That's part C. Determine the probability that a metal ball falls in the number 31 and a black slot simultaneously. The word "and" in there, those specific events can't happen together. So therefore, and the reason why that is because the 31 is red. That'd be 0, which is impossible for them to occur. That's what it means to the event, to describe the event. It's impossible. 15. A poll is conducted by the Genworth Financial. A random sample of adult asks, what age would you like to live to? Construct a probability model. So you have ages 18 to 79. Then it says 126. Then it says 80 to 89. 262, 90 to 99, 263, 100 or older. And it gives you 388. When you're conducting or making a frequency, or not a frequency, almost did it again, a probability model, first thing I would do, let's add all those together so that we know how many people were actually involved. There were 1,039 people. Now, to construct a probability model, I'm going to take the 126 and divide it by 1,039, which I almost misspoke and said frequency table, and if you think about it, they're kind of the same thing. $262 divided by 1039, which is about 2.5. When I go 263 divided by 1039, it's also 0.25. And 388 divided by that is 0.37. And I only went to 2 decimal places, so one of the things about a probability model, is that they should add up to be 1, like all the probabilities, and I got 0.37 plus 0.25 plus 0.25 plus 0.12, and I get 0.99, and the reason why I got that is because I rounded. If I would have kept them all the same, it would have been 1, okay? Just so you know. Part B, is it unusual for an event to want to be live between 18? No, it's not unusual because your number is 0.12. Remember, it's unusual if it's less than 5. Okay, that was number 15. 16, gestation period versus weight, and it gives the big chart there. It says, what's the probability that a randomly selected baby born in 2013 was post-term? So post-term, the number at the bottom, total was this, divided by the number that were born. So I have 225,044 divided by 3,948,828. And I get approximately 0.057. That's the probability that a random was post-term. What's the probability that a randomly selected baby born in 2013 weighed between those grams? So now I go over on the chart, and the total for that was this, out of the number possible, which is still that same big number there. And I divide them, and I get approximately 0.658 for part B. What's the probability that a randomly selected baby in 2013 weighed between this and was post-term? So when you think about and, okay, now we're doing the multiplication for independent events and whatnot, but one of the things I can do with this chart is it says it weighs this, so I go over to the 3,000 to 3,999, and was post-term. That number was 160,354 out of this many births for the year. So I don't necessarily need to use the formula because of the way that this table is set up. Okay, and I end up with 0.041. Part D, what's the probability that a randomly selected baby was post-term? So here's where the or part comes in, and here's where you're going to have to add it. So the 3,000 grams was this many births in the country. Post-term was this many births in the country. However, we had some overlap of this. So if you think about this, this is really nothing more than that addition rule I was giving you. It's just I'm going to make it a little bit more simple. Instead of putting them all underneath that divide thing, I'm going to take the 2596,802, add to it the 225,044, minus the 165, get that number, and then take that and divide it by my total. And so when I do that, I end up with 0.674. And that's part D. Part E, What's the probability that a randomly selected baby born in 2013 weighed less than 1,000 grams and was post-term? Oh boy. 26 out of that many. And then the 26 I got right from the table. And when I divide that, here's what I get. I get 6.58, and then way at the back, e to the negative 6. Remember that e to the negative 6 means 1, 2, 3, 4, 5, 6, 5, 8. So it says, is this event impossible? No, it's not impossible. We got it. It's just very unique or very, it doesn't happen very often. What's the probability that a randomly selected baby was born in this age category given that they're a post-term? And what we do for that one is, when we look at that, we've got 160,354, but the post-term was only this many. It wasn't all the births. So when I divide that, I get 0.713. Are the events post-term, baby, and weighs that grams independent? No, they are not independent of each other. It can happen where you have both. Okay, so that's where it's a no on that. Number 30, during the 1998 Major League season, Mark McGwire of the Cardinals hit 70 home runs. Of the 70 home runs, 34 went to left field, 20 went to left center, 13 went to center field, 3 went to right center, and 0 went to right field. Excuse me. What is the probability that a randomly selected home run was hit to left field? So, first of all, he hit 70 of them. We know that. So I took 34 divided by 70, and I ended up with 0.486. What that means is, if you go to 3 decimal places like that, that means that Mark McGwire would hit 486 home runs out of 1,000 to left field. What's the probability that a randomly selected home run was hit to right field? Well, right field is 0 out of 70, or 0. Was it impossible for Mark McGwire to hit a home run to right field? If you don't know anything about baseball or softball or anything like that, it's not impossible. He didn't do it. So you have to think about that in the context of the problem. It's not impossible for someone to hit it to right field. It just, for him that season, he just didn't. Okay? So that is your review. On Classroom, I'm also going to have the breakdown of your quiz. Your quiz will consist of 15 questions. Some of them will be multiple choice. Some of them will be what's the probability. Make sure you make a note card that has your formulas. Okay? You can have a note card that has your formulas. All right? So, on that note, that's all for this.